Shall we review for the final exam? Seem like a reasonable way to spend some time? Bam, all right, cool. One of the first things that we covered since the midterm was TDD. Remember TDD? Test-driven development, okay? When you're creating test cases before you write the code and then letting those test cases drive how you create your code, you're using, I'm sorry, what?
TDD.
What's it called? Test what?
Test-driven development.
Excellent, fabulous, that's exactly right. TDD is formal term used to describe process of testing from the outset of development. This means that you write every line of code specifically as a response to your test. How cool is that? Rule number 1, your test should always fail before you implement any code. Because you write the test case, right? If you run that test case, it's going to fail because there's absolutely no code to test. That seems pretty reasonable. You want them to fail, you want your test to establish a measurable success. In other words, as you write your code, suddenly magically you'll start to pass the test case. How cool is that? Because your test is failing now, it's clear what you have to do when you write your code. Basically, you're writing a code to pass that darn test case. Fabulous. 3 steps to test-driven development. Number 1, you start out in the red. Of course, your test fails because you don't have any darn code. Bam, you move to green. Your test passes. Yay, you're happy, you're thrilled. You tell your friends that your tests are passing. Bam, 3rd step, refactor. This is where you go back and you change the code to make it quicker, better, faster, whatever you want. But that's cool because the code already works. Remember, when you're refactoring, you're making your code better, but user arguably won't see any difference, but you'll know that it's better. What does testing first buy us? Well, first off, we produce better code because our code is being created specifically to hit the test cases. We create well-organized code because we know exactly what we're going to code. We're coding to our test cases. And we code that always does the same thing. Okay? Code is loosely coupled. In other words, if we make some changes, things aren't necessarily going to break on us. Fantastic. Okay, system testing. If you're going to do system testing, what do you need? You what? Because you can't do testing if you don't have a what? You didn't have a system, right? Okay. And what is a system, by the way? It's like everything. You take everybody's stuff and you pull it together and you call that a system, right? Okay? You have to use the system in order to ensure that it works, okay? You test the system in a situation that's as close to the real world as possible, and it's all about reality. That's the whole purpose of system testing. We're trying to make it look as real as possible so we can test it and see if the thing actually works in the real world. Why do system testing? You guys do the unit testing, right? You know that your code works. Why bother with system testing? What? Other people's code might not work, that's true. And maybe your code doesn't work when it plays with other people, right? Okay. Unit testing is fantastic and it's wonderful, but all it says is that your code works, right? So why do we do system testing? Well, unit testing can miss bugs that only show up when we put the different pieces together. Okay? System testing hooks everything together and treats the system like a black box. What we know about black boxes. Tests the functionality that the user expects. System testing exercises the functionality of the system from front to back using real-world black box scenarios. Seems like that might be important to know. Okay. Good system testing requires 2 iteration cycles. Remember, these are the guys actually developing the stuff. These are the guys prepping to test it. Then the guys who get done with, who are building it, turn it over to the testers. They start to test version 1 while they're working on version 2. Then the bugs from version 1 come back as they're working on version 3. So they fix the bugs from version 1 and they do version 3. Meanwhile, version 2 goes over here. They start testing version 2 and stuff comes over here. They fix the bugs. They test version 3. When they're happy with it, pow, cranks out to the customer. So it's 2 separate teams working on the same darn thing. How do you deal with bugs? Because bugs happen. Hey, part of the real world. No big deal. What is a bug? The little thing with legs and like really gross because it's got like feelers. Yeah, okay, no. It's a fault in your software. So bam! Tester finds a bug. Could be a fail, could be poor documentation, or man, the whole dang thing just might not be there. That's why it's not working, because it's not there. What do you do when you find a bug? Scream, yell, run around. Okay, that's all fine. But what's the next thing that you do? Do a what? A bug report? Do you write it down? Yes. What would you call the thing that you write down?
What would you call it right now? I would assume you'd be putting it into your configuration system.
What would you call it?
Bug report.
A what?
Bug report.
Bug report! Fantastic! Let's call it a bug report. Only because you said so, okay, but that's fine. Yes, that's exactly right. So when you find a bug, you make a what? Bug report, right? And what's the bug report going to be used to do? Tell other people in the organization, right? So you know about a bug, but if you don't tell people, what good is that, right? There's nothing really good. Test files up. Files of what? A what? Okay. Tracks the bugs, level of detail is critical. What are you trying to do? Error messages, steps to regrade, expected outcomes. You're trying to create a story, a task to fix the bug. Basically, you're trying to describe what you found. Because you're going to pass it off to somebody, and what they're going to have to do is actually recreate it. Okay? When it's time to fix the bug, you're working into an iteration. You've got to schedule some time to do it. You create the test first, because we know about TDD. Thank you very much. We mark the bug as fixed when we think we're done with it. Then we pass it off to somebody who's actually going to test what we did. They're going to check to make sure that our fix actually fixes it and doesn't bust a bunch of other stuff. When they're all done with that, we're going to update the what? The bug report, right? Okay? And then we're going to say, hey, it's all taken care of. And then we're going to remember the bug report existed, because remember these things can show up again and again and again. Why create a bug report? Well, it's a bug is an issue you have to deal with. Bugs have to be recorded and tracked. There's a bunch of different ways to do it. Bugzilla is a popular one to do it, and you use the bug track to do the following things: record and communicate bug priorities, because not all bugs are the same. Okay? Keep track of everything and what's fixed, what's not fixed, and stuff like that, and generate metrics. How many bugs have we fixed today? How many bugs have we fixed this month? Software. Ooh, now. So this is a little tricky part. So my TA took the test. She actually did really well on it. She ran into problems with this part. This is the part that she got struggled with. So I just give you a heads up. Pay attention. Okay. Software development process. It's actually the process, coincidentally, of developing software. It's the scoop it up sort of stuff like that. Good software process is all about prioritization. Remember, there's always more that somebody wants you to do than you're going to have time, energy, effort, or people to do. You need to make sure that you're doing the right thing in the project at all times. Your goal of a software development project should be what? Yeah. Why the hell, why are you doing this, right? Your whole goal is to produce what? Code, right? And to work. What's your second goal?
Then good code.
Yeah, good code's nice. I mean, I'd love to have good code. But if I can't have good code, what do I want? Code. I'll take code, right? You know that. Okay. And you should always be working to improve your process. Okay? That's key there. Okay? 3 things that make working software. Okay. First one is getting it done. Right? Am I going to get the working software if you don't complete it? No. Don't get it done, I don't get anything. Second thing is what?
Works and passes everything.
Yeah, you better be testing your software, right? And third thing is what? Making the customer happy, right? So I'm sorry, what are the 3 things that go into making a successful software? One is what?
Actually get it done.
Get it done. What's number 2? Test it. Make sure you actually do what you said you were going to do. And what's the third one? Happy customer, right? You deliver it and the customer's not happy, it's as though you didn't do any work, right? Okay. Things to do at the start of the new iteration. Okay, you got to revise. You've got to take a look and see where you're at. Because remember, stuff changes, right? Stories and tasks have to be revised. Ooh, that velocity thing. We talk about this a lot, but basically you have to reset your velocity at the start of each one, right? Take a look at how everything went last time. Figure out if your team's doing better or worse. Recalculate your velocity. Recalculate your estimates and velocity at the start of every iteration. 3 things. Oh, change. All right, so change sucks. We'll admit that. Okay, that's fine. When something changes, when your user changes their mind or something like that, it changes your life. It's going to change your life in 3 different ways. First one is it's going to change the user stories. Maybe there'll be new stories or old stories will go away, or maybe they'll just change some of the stories that you have. The second thing that they're going to change is what? Estimates, right? User has decided he wants everything to be purple. That's going to add 2 dips. Okay? And then the last thing that can change is what? Priorities, right? This wasn't important, now it's become super important. This was super important, now I don't care about it anymore, right? So 3 things that can change in your life are, number 1 is what? Number 2 is what? And number 3 is what? There you go. Make sense? I mean, all of them can change, and if they change, they have a big impact on your software development life, right? What you were planning on to work on, you might not be doing anymore. What you were not planning on doing, perhaps all of a sudden you have to do now. Boom! Oh my God, you found a bug. What are you going to do? going to have a big impact on your iteration schedule, right? If the software doesn't work like it's supposed to, then you're going to have to fix it. Okay, great. To fix it, it's going to take time. If you're spending time fixing bugs, that means that you're not spending time developing brand new shiny features for your customer. Got it? You're going to have to talk with your team. Your team's going to have to figure out how big of a deal this bug is. If it's not a big deal, it's a spelling error on some sort of thing on the screen. Who cares? It's not a big of a deal. However, if it's not working, it could have a big impact on your schedule. And of course, what you're going to have to do on each one of your bugs is come up with an estimate. How long is it going to take you to fix that bug? Because then you're going to have to work it in with all the other work that you're doing. Spike testing. You remember we talked about spike testing? So what is spike testing? It's when you've got a whole bunch of bugs. You inherited some software or something like that. It's got like 20 bugs. And the question is how long is it going to take you to fix those 20 bugs? The answer is I've got no freaking clue whatsoever. So what you do is you pick off a bunch of them. Let's say we pick off 5 of the bugs. I'm just going to work real hard on getting those 5 bugs taken care of. That's what spike testing is, right? Now it's going to take you a certain amount of time to get those 5 bugs taken care of. But once you do that, you're going to know how long probably it's going to take you to get all 20 of those done. So if it took me 5 days to get 5 bugs fixed, I can sort of tell you it's probably going to take me 20 days to get 20 bugs fixed, right? And that's exactly what spike testing is all about. You do one burst of activity, you observe what you accomplished, how many bugs was I able to fix, and then you use that to estimate how much time it's going to take to get everything else done. Does that make sense? Do something hard and fast for a short period of time and then use that as a measurement to tell you how long everything else is going to take. Time. Spike testing plan, test cases. If I have 4 bugs fixed in 5 days, I can do some math and I can figure out it's going to take me like 7 days to get everything else fixed. Remember, it's total 13 bugs. I take 4 off. I've got a velocity of 8. It's not 3 seconds. It's just math. It's not that big of a deal. Functional decomposition. What is this? So you killed somebody and you have a body. Now what?
Find out.
Come on, you've seen CSI, you know how this one goes, right? Okay, maybe that's not functional decomposition. So what is functional decomposition? Well, it's functional, so we're good with that, and it's going to decompose. So what is decompose? Breaking down. Congratulations. You've killed people before. That's very good. Excellent. Yeah, that's right. So functional decomposition, it seems like we have a big function, and we're going to break it down into smaller or easier parts. That's exactly right. So you decompose the function or module into smaller modules, right? So create a traffic control system for me is my challenge to you. Is that a big problem?
Yes.
Potentially it is. Can you do big problems? No. So what are you going to do when I say create a traffic control system? What are you going to do with it?
Find out what I do, but
Right. Make it into like smaller problems, right? Maybe handle a red light, right? And then maybe handle like 2 red lights. And then handle like a left-hand turn arrow. And maybe handle like flashing lights. Okay, right. So we did an example of college course registration and enrollment. Remember we went through that sort of deal. There was a bunch of things. Modify and delete students, modify and delete courses, add, modify and delete sections for a given course, and register and drop students from a section. Remember? So the big problem was college course registration. And then we broke it down into these 4 smaller ones. Can you see the functional decomposition happening here? So we got closer and closer and closer. So functional decomposition is where you take a big problem and you break it down into smaller problems. Because you can't solve big problems, but you can solve smaller problems. Oh, here's an example. Okay, so this is our college registration course. So we started out here, main, student courses, selection, registration. Students can add, modify, and delete courses. Courses can be added, modified, and deleted. We've got sections we can add, modify, and delete. And registration had register and drop. So that was one functional decomposition. And then we talked about the fact that you could actually come up with another exact same solution where you had students, courses, sections, and registration, and then everything was based in the database for your add, modify, and delete. Both of them are fine. Both of them are functional decompositions. Make sense? What makes a good implementation? Good code is readable. I can take a look at your code and figure out what the heck's going on. I can maintain it. If I have to edit your code and update it, I can at least figure out what's going on. It runs quickly and fast, so that's good. It's traceable. In other words, I can take a look at your code and figure out which user story it relates to. It is correct. It calculates things the right way, etc., and it's complete. In other words, here was 12 user stories, and you implemented 12 user stories. These are all very good. And oh, by the way, each one of these has some trade-offs associated with it. Comments! We love comments, don't we? Comments are a good thing. We also discovered in this course that comments can be sort of a bad thing if we're not careful. They can help or hurt program maintainability, and there's two problems with comments. The first one is what? They're a distraction, right? You know, I might have to read through like War and Peace to figure out what your code is doing, like sort of distracting from me sort of focusing on what's going on. And also, of course, here's the other kicker. What else can be wrong with comments? They can be flat out wrong, right? Do you execute comments? Do you run them? Do you compile them? No. Is everybody ever going to check comments? Not really. Unless somebody reads it and points it out, it's going to be wrong forever and ever and ever, isn't it, right? They can also become outdated as the code changes. So yeah, maybe you got it right originally, but then you went back and you tinkered with your code and you made some changes and stuff like that, but you forgot to make changes to your comments. And when that happened, then all of a sudden everything was wrong. And of course, they can be wrong from the start because you never execute them. It's a bit of a trade-off when we do comments, right? They do help clarify code. Yeah, we like that and stuff like that. But there's some duplication going on there, right? If your code was clear, I wouldn't need your darn comments, right? I could just read your code and figure out what was going on. It does take time to create them, and of course, errors can show up. So comments are our friends, but they can come back and bite us if we're not careful. You can use comments to justify bad coding practices. I'm sorry my code's so complex, but here's what I really meant to do. So I just wanted to put a couple comments in here to explain it. Yeah, right. Don't do bad code in the first place, right? Alternative, if your code is so fantastically clear, you don't really need that many comments, right? It's a good goal, but generally we always end up adding some comments no matter what. Debugging, yay! So what is debugging? We find, we locate, we fix problems with your code, okay? Generally errors are found by testing. That's where most errors come from. Unfortunately, some errors come from people actually using the code and saying it doesn't work. That makes us very sad when that happens. It's a very iterative process. In other words, we go back in and we fix and fix and fix and fix, okay? Performance optimization. Man, it must be a great thing to make your code run faster, so we should always spend a lot of time working on that. Is that a correct statement? Why not? Well, you do want to make sure that it works. And assuming that it's worked, we should spend a lot of time making it work faster, right?
Well, is that a priority?
There's a fundamental question. Does it actually have to run faster? If it doesn't, then no, you really shouldn't spend any time on it. Also, here's the trick with it, though. When you optimize for performance, something else is going to take a hit. Okay? If you change your code to make it run quicker, better, faster, then you're going to have to make changes to the code, and probably what's going to take a hit is readability or maintainability, right? It's going to be harder to figure out what you're doing because you've done some clever things to make it run faster. And it's going to be harder to change and maintain that code because it's going to be tricky to figure out just what the heck's going on because you did special things to make it run faster. So if you don't need to make it run faster, don't put the complexity in, right? Okay? Oftentimes people worry about performance way too early. Oh, I want this to run fast. Oh, shut up. Get it to run first, and then come back and worry about making it run fast. How to optimize performance? Well, we can start with these fancy things called profiler tools, which you run, and then what it does is it says where is your program spending all of its time. And then once you know that, you figure out where your bottlenecks are, and then you know where you should make changes in your code. Because you don't want to change everything in your code to make it run faster, because it probably doesn't run most of your code most of the time. It's just for the bottlenecks. You review and optimize those places where you have an impact on your performance. But of course, after you do that, you have to run the profiler again to see if you've helped or hindered things. Cost of optimization. Well, you know, it costs a lot of money, actually, because it takes a lot of time and effort for a programmer to spend optimizing your code. A fundamental question you have to ask yourself is it worth it for me to pay to have a developer make their code run faster? Or should I just say, screw it, and go out and buy a faster piece of hardware? Woo! That would probably solve my problem right there. Refactoring. We talked about this just a bit. Refactoring is exactly like if you write a story. You write a story the very first time out, it's a fine story. It has an opening, a middle, and an end to it, right? But then you're sitting around thinking, wow, I could probably make that story better if I changed this and this and this, and you go back and you rewrite the story. Same thing you can do with code. So your code works, and it works correctly. Good job. But then you start thinking, wow, I can make it clearer, I can make it faster, or I can do it in fewer lines. Okay? That's exactly what refactoring is all about. The reason that you would refactor is because you've got duplicated code in your code, or your code's too large, or your functions are too long, or a whole bunch of other things. You fundamentally want to make your code easier to read and easier to maintain. That's why you refactor. Okay? You can turn a code fragment into a standalone function. You can replace a body function with a new algorithm. Perhaps you've got a sorting algorithm that you're using. And then you discover there's a quicker, better, faster sorting algorithm for the type of data that you're dealing with. So you rip it out, you stick a new one in, maybe move an algorithm around, or divide a function into two functions because the function was just too darn long. Okay. Now, when we release software and we give it to our customers, there's one thing that we expect to occur, and what is that? What do we expect to occur when we release software to customers?
Problems.
They're going to complain, right? We would expect immediately upon releasing our software that our bug reports should go through the roof. And we hope that over time they mellow out. So we're expecting to have more bug reports right off the bat. Okay? Now, question for everybody. You release software, you give a brand new piece of software to your customers, and your bug reports do not increase. Is that a good thing or a bad thing?
Well, did I get the money already?
Yeah, you have the money.
Okay, then I don't care.
Well, no, but you want to get more money. Yeah, sorry about that. Okay. So, we're saying it's a good thing or a bad thing? We're saying it's a what? A bad thing. And why are we saying it's a bad thing? Nobody's using the code. You gave them new code and they're not using it. That's why they're not getting back to you, right? Now, at some point in time, they'll turn it on, they'll start using it, and then are they going to complain? Yeah, right? But you may not be ready for it, right?
Their warranty will expire.
Their warranty will expire. Or the people that you hired to staff your call center, will you let them go because there's just no need for them, right? And then all of a sudden you go slam later on. All right. How do you fix a customer problem? Basically, you take a report, you talk to your technical fix group, they accept or reject the problem. If it's rejected, you got to tell the customer, yeah, we're not going to fix that because it's not really broken and stuff like that. Depending on priority, a new code version may be created and you give it out to the customer. And of course, you'll update your FAQ database so the next time somebody calls in with exactly that same problem, your smart, bright people who are sitting on the other end of the phone line can tell them exactly what the fix is. And that's it. That's all you need to know about software development to do well on the final exam. Doesn't seem that hard, does it? No. Okay. Well, how about if we take a break? How about if we come back at 9 o'clock? And then why don't we go over the over 400 slides that I have talking about what you need to know about Python to be successful on the final exam. Fair deal? Okay. Fantastic.